Hello guys, welcome back to my channel. Today I'm going to talk about broadcasting in Spark. Before going to broadcasting, I want to explain why this broadcasting is necessary with a small example. So let's get started. Let's assume I have a data frame with column P and column X and another data frame with column P and column Y. If I perform joins on these two data frames, then the expected output will be column P, column X and column Y. What if I perform these kind of joins in Spark environment? Let's assume I have a Spark environment with 3 node cluster, node 1, node 2 and node 3. When I perform joins in this kind of environment, then the first thing that happens is partitioning. So let's assume the data which I have is partitioned in this manner. Node 1 contains P1x1 and P3y3 data. Node 2 contains P2x2 and P2y2 data. Node 3 contains P3x3 and P1y1 data. So if I want to perform a join on P1x1 which is supposed to map with P1y1 which is in node 3, then node 1 will be in touch with node 3 and communicate with node 3 to access the data from node 3 to node 1. Same way, if I want to perform join on P3x3 which is supposed to map with P3y3 which is in node 1, then node 3 will communicate with node 1 and access the data from node 1 to perform the join. During this process, there will be a lot of data shuffling happens. So this data shuffling will decrease the performance of Spark code. So we have to avoid the data shuffling over here. So what to do? When you perform normal joins in Spark, data shuffling is happening. So how to overcome these kind of scenarios? What we supposed to do? Then we have to use broadcasting. Broadcasting is one of the optimization technique in Spark which will increase the performance of Spark framework. So let's go back to the previous example and see how the broadcasting will fit in these kind of scenarios. Let's assume the data frame 1 as T1 and data frame 2 as T2. When I apply a broadcasting on T2, then the copy of T2 will be saved on each and every node. So when you apply broadcasting on a data frame, the copy of that particular data frame will be saved on each and every node. So that too in memory. So if I want to perform a join operation on P1x1, this P1x1 will access the data from T2 copy and join will happen. That too within the cluster without communicating any other node. So this is how broadcasting will help to reduce the data shuffling. When you cannot access the data from different node, then there won't be any data shuffling. So here the data is accessing within the node itself. So there is no data shuffling. So there is no shuffling. So this is the optimization technique we use on joins. So let's see how we can do it in coding perspective. I will be showing two snippets. One is in Python Spark and another is Scala Spark. So if you can see here, in Python Spark, we are using large df dot join of broadcasting on smaller df. So remember one thing, whenever you do broadcasting, you're supposed to do it on smaller data frame itself. Because if you do it on larger data frame, then the more memory will be consumed to store it in memory of each and every node. So it is preferred to use smaller df because it is easy to store it in memory and the memory will be less consumed. So even in Scala also the syntax is same, large df dot join of broadcast of smaller df. The only thing that is different in Python Spark and Scala Spark is the way you import the broadcast. So guys, this is how you have to code it in Python and this is how we have to code it in Scala. I hope this tutorial is useful to you. Thank you.